Hey Google, connect to my computer.
Okay, looking for paired devices. 545. 145.
Okay, all right. I hope this works. You guys can hear me, right? Does someone say something now? Maybe I can hear
Yes, now,
you.
Professor?
Yes, I can hear you. Thank you. Yeah, all right. Switch on your cameras and you can be ready to go. Yeah, welcome to the second of the 5 meetings. There's only 3 more meetings to go after this, I think. So make the best of it. As usual, this meeting is not meant to be me lecturing you guys, okay? So it is basically you guys talking to each other. It is being recorded, so yeah, for the benefit of the ones who couldn't make it today. So feel free to talk to each other. No sharing of quest code, no sharing, no asking for specific solutions for quest problems, but totally okay concept discussions. Concept discussions okay, and even if you have a certain operation that you need to do in your quest, like recursion, or well, you shouldn't be doing any recursion in CS2A. Okay, I don't think there is any recursion required to pass CS2A. In fact, you shouldn't be using recursion at all until you get to CS2B, because there are certain important things that you need to know about recursion before you actually start using it. So don't. But other things, right? For example, how to use classes, methods, scope of objects, variables you create. I'm looking at some very interesting posts that you've made in the forum. So thank you all very much. It's interesting and shows that you're all thoroughly engaged and trying to find out as much as you can about C++, which is really cool. Okay, so yeah, that's all I want to say. I don't have anything to say unless you guys have any particular questions that you want me to answer. So I want to just hand it over to you guys. I'll turn the laptop around to face the garden so you guys can talk. So I'll take a look at the video later on.
Could I ask you a question really quickly?
Yeah, sure, Kyle, go ahead.
So in Quest, I think this is 4 with the get GP terms. It seems like all of your answers have a total digit count of 6. So whether that's like 2 on the left side of the decimal and 4 on the right side of the decimal, or 1 on the left side, is there like a certain way to get that? Because like I was running into a problem where I just put my answer in a double and then concatenate it into like a string in the correct format, and mine tend to be more than 6 just because I put it in a double. I've been doing work to like basically reduce it to 6 digits, but does that mean I need like to like round it as well? Because since mine are like more than 6 digits and yours are 6 digits, the last digit seems to be rounded up or down depending on whether it's greater than 5 or less than 5. I'm just wondering if there's like some like printf command to like make it a total of 6 digits without doing a whole bunch of work.
Great. Yeah, well, good question. Well, by the way, I mean, if you can use printf, there's no reason why you shouldn't use printf. Okay, so you're welcome to use printf. Although, C has a different way of doing this. It is absolutely possible. It is actually very straightforward and easy, and I'm not going to tell you that, but hopefully one of your classmates can tell you, right? Because when you start talking about this later on, after I hand over to you guys, maybe one of you can tell Kyle how to get print according to a certain format. And if nobody can, just call me and I'll come and show you. In fact, even better would be if one of you shares your screen, or even better than that is if one of you asks Kyle to share his IDE, or it doesn't even have to be an IDE. You can just go to cpp.sh or onlinegdp.com. One of the sites will do, because it's just 2 or 3 lines, the formatted print that you want to check. So one of you could tell Kyle to go to the site, and then you guys could basically walk through a 3-line program. It's only 3 or 4 lines, right? And the modules, and there's a whole lot of ways in which you can do it. There are very easy and straightforward ways too, and so it will be a very interesting and worthwhile exercise for the class, for Kyle or someone to pick up the screen and code a value in which you calculate something. Maybe calculate 1/3 or something like that, which is bound to have, you know, an infinite number of decimal places. And then you say, well, I've got 0.3333, but I want to print only 6 decimal places. I want to print only 7 decimal places. I want to print, 0.3333, right? So I want to have a certain number of zeros, because, you know, zeros are omitted usually, isn't it? So C++, any language really, any language gives you 100% control over these basic IO. This is all very basic IO. And so every language you will learn, Python, Java, C++, has a way of doing this. They're all very common and very similar too. So if you learn one, it'll be very similar in the other languages. So that would be a great opportunity. Just make a note of this, Kyle. So after I hand over to you guys, maybe so one of your classmates can help you answer that. Or actually, you know, do it on screen so that everybody can see it and know exactly what the hell is going on, right? So it's a very simple thing to learn, and also it's useful to learn. I also very frequently skipped by beginners, right? Or even programmers I know, you know, who've done a lot of stuff, may not remember. That's right. They may not remember how to do formatted printing, and they usually have to go looking. In fact, you know, I even though I've coded for a long time, if I want to print for a certain print according to a very rigid specification, I usually look up, right? I usually look up. So there's all these ways you can do it. So I'm glad you asked that question, because it is time that Quest 3 is coming up and lots of people are working on Quest 3. So that's fantastic. All right. So is that okay with you guys? Rather than me guide you through a little program, it'll be fun if one of you guys guide Kyle through the program. And it's only 4 or 5 lines. Okay, it's not a big deal. 4 or 5 lines. You should feel free to write. And if Kyle is not, you know, feeling up to it or doesn't have a computer that connects and all, someone else could do it too. That's no problem. Okay, anyone who has access to a computer able to share a screen should be able to take up the screen and say, well, I'm going to write a program. Well, you guys can talk me through it. I'm going to type. That's even better, right? And go through that, and it'll be fun. It'll be fun. I can guarantee it'll be fun. Okay, to figure this out. Eventually, when you all run out of ideas and no other questions to ask, and you still, you know, want to say, I want to be still continue with this class because of such a fun group of people. I don't want to let them go, right? So yeah, come up with an idea. Come up with an idea that we'll all code together, like I did in my regular face-to-face Zoom classes. Every class, usually we pick up some interesting project, or some student proposes an idea, and we code it. And you can look at our past videos. I've made this point before. And every single class we're coding something. Usually it is some special effect of, you know, characters dancing on screen, or some silly kind of animation that we create using just characters. Yeah, I think last quarter we also did another fun thing. We tried to model the path of a bullet or a projectile that is shot off the edge of a cliff, right? And it doesn't need a great deal of computation here. It's just basic physics. All you need to know is when a bullet leaves horizontally, its horizontal velocity is fixed. Horizontal velocity doesn't change at all. Yes? Well, assuming there's no air resistance, okay? If you fire a bullet off in space, it's going to keep going straight, isn't it? Until it hits a planet or an asteroid, it's going to keep going straight for a billion years, maybe, right? Because eventually it's going to keep slowing down, because it's going to encounter the odd hydrogen atom, right? Every cubic meter of space is going to encounter one hydrogen atom, maybe, and that hydrogen atom will slow the bullet down, so that after billions and billions of years, the bullet will come to a stop, even if we shoot it into space, right? Because there is going to be resistance. But on Earth, that whole thing is magnified, because, you know, there's so many air molecules that are hitting the bullet, it'll slow down very quickly. But assume, for the purposes of the simulation, that there's no air resistance. So when the bullet is shot, right, what is the horizontal velocity? It's the velocity at which it leaves the muzzle of the gun. Yes? That's not gonna reduce at all. However, what is the vertical velocity, vertical speed at the time the bullet is fired?
0.
Can someone tell me that?
It's
At
0
the time
at the beginning.
Sorry, who said that?
0.
Oh, Kyle. Yes, thank you. Oh, Kyle. Oh, where's the other Kyle? Oh, we have two Kyles in class. Okay. Yeah. All right. I gotta say Kylie. Oh, yeah, but Kylie. All right. Yeah. So good. Yeah. Fantastic. All right. So when the bullet is fired horizontally, its velocity downwards is 0. No, it is not. It is because it's not being pushed down, right? It's only being pushed horizontally. So horizontally, it's got velocity 0, velocity downwards. However, Earth has gravity, and therefore any object you drop has got to start, falling downwards. It's being attracted by the Earth. Therefore, the moment the bullet is fired and it's not being held by the barrel, it's going to start falling also. But initially, it's going to fall very, very slowly because it starts off at 0 and gravitational acceleration is going to kick in, right? But the acceleration is going to increase the speed, constantly increase the speed. So if you fire it off from the edge of a cliff, right, it's going to go at the same horizontal speed, but its vertical speed is going to keep on increasing because Earth is attracting, and so what you will end up seeing is not a line like this. It's not a line like this line, right? It's going to be a curve like that, and it'll be a parabola. And in fact, we did this in class. We printed out stars, okay, stars, some character, cross or something like that. We printed out a star saying, all right, after 1 second, the star is here. After 2 seconds, the star is here. After 3 seconds, the star is here, and so on, so that we actually get the shape of a parabola on our screen. And that is the trajectory of the bullet as it falls. Okay, and the reason I'm mentioning this now is that this is something that you could do in less than an hour, because we did it in less than an hour in class. Why? There were a couple of bugs that students had to fix later on, but they fixed it, and they posted the solution in the Reddit discussion forums within an hour of class or something like that. Okay, so it can't be all that hard. So that would be an interesting project for you to do. Or you can take strings and say, I'm going to flip it around. I'm going to make that string rotate. So you have a string hello, and you can make it rotate horizontally. You can make it rotate horizontally so that it's not you can vertically it's hard, but you can make it rotate horizontally. So the letters kind of go like that, and rotate the letters, and you can do those kinds of fun things. Well, the sky's the limit, like I say. So it doesn't have to be either of these. You can pick any project you want that is doable within a couple of hours, and you can just do it, right? And anytime when you guys are working on it, and you think that you need to do something, and you're not quite sure how to do this, and none of your classmates are able to also tell you how to do it, you just call me, okay? I'm just going to be here. I'll come back and I'll take a look at the code. I'll say, well, if this is what you want to do, you can do it this way, okay? So I'll help unblock you every time you're blocked. I'll help unblock you, and you can continue, and hopefully you'll have an interesting project done by the end of this class. Yeah, and well, it's not really a class, really, isn't it? Because it's all informal and unofficial, and you guys are just turning up of your own volition for a non-mandatory class, so which is absolutely fantastic. So you should feel free to do all of that, okay? And I'm going to be here to help you. You can use any of the techniques you've learned so far, except, well, arrays. Yeah, I think we start using arrays in the regular class. We start using arrays in week 5, which would be week 2.5 here. Yeah, okay. We are in week 2.5, right? Is this a conclusion of week 2 or this is a conclusion of week 2, is it?
Yes, I believe so.
So you're coming up to the use of arrays. I don't think I'm using arrays until quest number 6 or 7. But you can start using arrays now. It's not a big deal if you want, right? There's other projects you can do without using arrays too. That's also fine. Okay? So you can do those things, and I'll be here to help you out if you get stuck. And if you have any other questions, ask me before I turn the laptop around to face the garden, so you can just continue to talk. When after I hand over to you, the only thing I really request is that keep the airwaves occupied by just talking, right? Even if you're talking about a movie or some show you watched yesterday, that's fine. Although, keep that to a minimum and talk about the subject as much as you can. And the reason for that is that I'm not looking at the screen, obviously, so I'll be out there. But if the airwaves are occupied and I hear voices, I know you guys are still around. So I don't have to come back here and check if, hey, everybody's gone, I should stop the recording. And right. So please keep the airwaves occupied. And also you'll find it's fun, right? It's more fun if you're just talking. And like I said before, I don't know if I mentioned this in the previous class, just use this as practice for developing a tech talk show. Okay, a tech talk show. And everything is now moving into the next generation of entertainment, right? You don't have long form content anymore. Even if Netflix and Prime come out with these 2-hour movies and 3-hour movies, I bet most people are just going to Facebook and watching these 10-minute clips and TikTok for 10-second clips, because they're just taking over the world. Because I don't know. Unfortunately or fortunately, people's attention spans are I don't know if it's because of attention spans, right? Because I know people who like these short form videos, but they can also just totally get engrossed in a 5-hour lecture. And so I don't think it is we should blame people saying, oh, attention span of people going down, that's why they're favoring TikTok over a long form. No, I don't think that's the case. Maybe maybe there's a lot more research that needs to get done to establish if that really is the case. But I think that technology is now evolved to a stage where short form content sharing has become easy. It wasn't so easy before, right? Because previously you have, if you have trillions of videos, it's hard to index them, it's hard to serve them, it's hard to search in them, and all that was a pain. But now nothing is a pain, really, right? You have, exabytes of content up there, and I can just send a spider into the cloud and say, go there, just crawl all of the videos, recognize all of the speech, recognize all of the gestures of the participants, and record that metadata here and record all the speech here. And if the content is too much for you, just clone yourself and make yourself into 2 spiders. Okay, so all of that is easily doable in any cloud, really, Amazon or Google or Azure. You can go to any cloud. You can just basically create a lambda. A spider is a lambda, which is a lambda is basically a function that doesn't have a name, right? A program that doesn't have a name is called a lambda, right? So when people say, I want a lambda, that's what they mean. They say, I want a program, but I don't want a name for it because it's just an arbitrary program. Which means that it's just a program. If the task is too much for the program can just clone itself like that. Okay, and then they start attacking the problem. If the problem becomes too much for these 2 guys, they'll clone themselves again, 4, right? So I just need to write one program and release it into the cloud and say, go and index all of those exabytes of video. And depending on how much money I have, if I'm Microsoft or Google or Netflix, they have lots and lots of money, right? And these lambdas are really cheap. I'm running lambdas. They don't cost me any money at all. So they would say, I'm going to write this program, go into my YouTube stored in Antarctica or somewhere, right, under the ice, and index all of those videos, right? And in a couple of days, it's all done. Bam. Because it's not just one, it'll just go, fork itself, clone, index. Everything is done, finished. Okay, so everything is possible now. So that's why I think these, short form videos are becoming the rage. And why should the short form videos be restricted to mindless TikTok content, right? I think TikTok content it's not always mindless. Some of them have interesting gems. I haven't watched a lot of TikTok. My daughter used to watch a lot, some of the TikTok in back in the day, I think. But I watch short form content on Facebook, right, and on YouTube also. Previously, I wasn't a great fan because most of the content wasn't tailored to my tastes. And most of the content that I used to get wasn't really useful to me. I'd watch the first 10 seconds and say, okay, go next. But I think one of the important things that we do when we look at, when you scroll your Facebook feed and all these feeds that you do is don't give up on the videos or content that you see that you don't like and say, well, this entire platform is no good for me because it's just giving me lots of shit. Okay. What happens is that, no, you should actually scroll past them. Okay, we come across a video, scroll past it, right? And find something that interests you and watch it. Okay, that's all the cue the AI needs. Okay, that's all it needs. If you do that consistently over a period of a month or so, right, it will learn what you need. Okay, and it will only show you the content that you like to watch that is useful to you. So if you are, for example, a poet or a teacher, right, and you are looking for content saying, oh, creative ways of teaching, right? Let me go to Facebook or Google and search for YouTube, creative ways of teaching. It'll give you a bunch of things, right? You watch 4 or 5, the next time you go and search for the search term, or even the system itself may recommend it to you, say, go watch this playlist. Okay, that would be curated. And in fact, that playlist would not even have been created by another human saying, well, you know what, people who want to watch interesting things, interesting ways of teaching, I'm going to create a playlist of 10,000 videos, or even 100 videos curated by me, right? You don't say. And the funny thing is, these days you don't even have to look for these things that are created by humans. What you would do is you just watch a few, and the next time you go, after a few times, you get a curated playlist. But this wasn't created by a human. This was created by AI. The AI that looked at what you liked and what you didn't like, and then put together a playlist for you. So these days, if you go to Facebook, that's why many people spend more and more time on these platforms, is because the feed that is coming to you is curated for you. And if you're interested in something, the platform will make sure you get all of the information that you need, also selected so that the level of the information presented is the level that you can actually make use of. So if you're trying to learn computer science and you go to YouTube and look for computer science videos, right? During the early stages, you'll get videos about, how to do for loops, how to do, this kind of loop, how to use ternary statements and things like that. They're all selected for you, right? During the early stages, because those are the kinds of videos you're watching. But over time, you will notice that the videos that are selected by the artificial intelligence and presented to you have been tailored. So over 6 months, you'll find that the videos you're getting are no more about basic control structures. They're talking about what happens when you take a stack and invert it. How can you invert a stack, right? This is a data structure, and you want to go from here to here, but there's no one way to do it. What's the best way to do it? There's a way, right? This is how you can do it. And all of those are computational problems. And depending on where your computational interest goes, you'll get new videos that are automatically tailored, and you don't need to depend on humans anymore, right? So you can get the machine to do a lot of this work for you. And in which case it'll be more objective, it'll be more tailored to your personal tastes, because all said and done, if someone else does it for you, no matter what, it's going to have the other person's bias also. Even if they didn't want to do it, it's going to have the other person's bias somewhere, right? So it's going to, or their preferred ways of watching videos, or their preferred taste in the anchor that's presenting the video, right? All of that will be factored in. But with a machine, you are telling the machine, this is exactly what I want. Go ahead and find it, okay? And the spider will do the job for you. And well, not just the spider, obviously. This is a whole lot of programs, that some of the programs that you guys will be writing in the future, right? To say, hey, I got some content, I want to tailor this for people on Mars, people on Pluto, right? I don't want to show Pluto people Earth videos. I want to show them, what happens. When did you guys become a planet? Okay, all right. So that kind of videos. So those are things that the AI can do, and you guys will be doing in the future. So take this as an opportunity. And maybe even offline, you can, decide amongst yourself, right? Hey guys, I want to do a, 10 minute practice session on a topic, right? And then someone else says, well, I'll take over from there. I'll do another 10-minute session. They may all be different topics, not continuing, not related to each other, but each one of those will be a section that will, if you keep doing repeatedly, will improve. And maybe in 10 classes, you will be able to produce an incredible video with one person leading that discussion, and 5 intelligent people participating in it. That's all. 5-minute clip, one person leading a discussion on some topic in computer science, and 5 other people asking interesting questions. And that's a 5-minute clip. You can share it, and who knows, that may actually take off, because those 5 people asking questions, they may be the exact same questions that every other beginning programmer wants to ask, right? And they will get asked, and these videos will become useful, and everybody will benefit from them, right? So those are all ideas you can have. And as I said, I'm going to be here, right? I'll be here. I don't want to cramp your style. So if you don't have any questions, I'll just turn the laptop around, and you can go ahead and talk, and clarify your doubts with each other. And if there are no more doubts, you can say, hey, I got an interesting idea. Can I have 10 minutes so that we can do it together on screen? Which means that you can code it, or you can say, can we talk about this for 10 minutes, right? And initially, if you've never done this before, your talking will be contrived, and don't feel self-conscious and say, well, that's not how Oprah would do it. That's not how, Jay Leno does it. No, they've been doing that for, decades, right? So you can't compare yourself to them. So you got to say, well, the first couple of times it's going to really look awkward. It may look like I'm just coming up with these questions that I'm pulling out of air right now instead of having thought about it before. I'm going to look like a fool. Who cares? Okay, it's like a 5-minute clip buried inside one of these videos. Nobody really cares about these things. Look like a fool. Looking like a fool is the only way to make sure that you don't look like a fool later on. Okay, so, and this is your chance, because here you're being given a chance to be a fool. Okay, so how much better can it get? So because everybody wants to be a fool, everybody wants to act crazy and stupid, but out there you can't do that, because people will say that guy's really stupid, right? So here you're saying your job is to be stupid. So now you can go all bonkers and say, hey, I got a chance to be stupid. I'm going to do all kinds of crazy things here. Just don't feel self-conscious. Talk about these questions. Ask questions ad nauseum, right? Doesn't matter. These questions, as you ask them, will keep getting better with time, and you can measure them, right? In fact, you can go back to all these videos, and if you're going to do my 2B, yeah, you can do my 2B. You can do my you can do my 2B in fall, and you can do my 2C in winter. Hopefully, I will offer 2C in winter also. I want to offer all 3 sections every quarter, because for now until like okay, so you can do my 2B, and then we'll have the same kinds of meetings in 2B also, and you'll see that your the whole thing is taken to a next level for you, right? Not the class, just the discussion you're having with your classmates, and the responses you're able to elicit. And eventually what will happen is that as you guide the topic, you'll get a sense. You'll automatically get a sense for the kinds of questions other people ask, and so you'll be able to anticipate these questions before they're asked. And so that and it's important for you to be able to anticipate questions before they're asked, so that you can set up for the question to be asked in the best way. Because some people, you have a question, you're explaining something, and someone has a doubt, and they're going to ask the question, that's going to come up, right? But maybe if that person asks a question right now, it's not going to look so good because they're still missing something critical, but you've anticipated the question. So you can say, I'm going to set it up now so that it's super duper easy for that person to ask a question, right? So you basically now explain a few things and nudge the person in that direction, and bring them to a place where they can't help it, but they ask the question anyway because they know, right? So this is the best time to ask a question, they'll ask it, right? And that's what distinguishes a good clip, a good segment from another awkward segment in which both the participants are trying to steer towards something that needs to be spoken, but neither is able to get to the place, right? So and those are things that you will consciously be able to identify. It's not just computer science, okay? It's computer science. Any art really is not just the art itself. It's also the art and how the art is shared with other people. Because if it's just the art and you're happy with it, that's fine. But many people want to do art and also make other people happy with it. So, and this would be great practice by saying, here's something I know, but I don't know it 100%, or I want other people to know it also. So let me try and explain it and see if I get the same kind of visceral joy that in their eyes as I got when I first, right? And then you explain it, and then that person is still not able to appreciate it, because you can see this, right? You can see when people appreciate things in their eyes and say, well, okay, now let's try to explain it in a different way. Okay, and you can try all these things, and those are the things that we keep doing again and again to get really solid in being able to anticipate questions before they come to us. And that is really the trick, right? And even exams, it helps you, because before you go to an exam, when you've been studying, you will actually know, you will get a sense of what kinds of questions could be asked in the exam. After you've seen some questions, you'll know, any class, even math, as long as the teacher is not picking questions out of a textbook, because textbook questions you can't tell. But I know I had a math teacher when I was in college. I had a math teacher who would never pick questions from a textbook, right? Every time he would make his own questions. And then the cool thing about that was that once you get used to the way that he's asking questions, you can actually anticipate the kinds of questions he's going to ask based on the material you're studying. So, and that is very useful because, that way, both the teacher and the student are on the same page all the time. So both can help each other. It's not like I'm helping you, right? That is the most important thing. Students always think, I'm going to school, teacher will help me master these things. No, you go to school and you got to help the teacher understand what it is that you need. And the teacher will then help you saying, hey, try this, try this, try this, right? I've had experiences where I thought I had a bulletproof explanation that will always work for some algorithm in CS2C. And I was so sure, right? And it was a really hard problem also. So I was really looking forward to students getting stuck there. So they come and I can help them. Say, hey, here, this is the explanation. That's why it works. Can you see that? And it worked every single time, but it didn't work for some people, right? And how do I discover that? But once I discover that, I know, wow, you know what? These people are thinking like that. I'm coming like this, right? So let me see if I can figure out an explanation that comes that way. And those are things that you will find out too. It's all fun. It's all fun, right? Because anything you take, it's the total value of it is not realized by looking at it in one direction. Okay, you got to look at it from all directions. Then you can say, wow, that's what it is, right? And you get a true appreciation of it. And also the other reason why looking at things from multiple perspectives helps is that it will entrench itself in your memory better. I think that's my theory. Okay, because if you know one thing one way, there's only one filament that connects it in your brain. Okay, but if you look at, it's like a spider web, right? If you take a concept and you say, well, I've understood it mathematically, I've understood it computationally, I understood it, in a completely different logical way, right? All these different ways, then you have many different anchor points, right? They're all holding it, and one of them cuts loose, the others will hold it in place until you can regrow that connection. So that's when, a concept becomes properly entrenched in our minds. That's what I think anyway, because in my experience, learning something one way makes it easier for me to forget it. So I usually do what I do is if after I've learned it one way, hey, there's no point in learning many ways to do things until after you've learned it one way. So make sure you learn something one way first, but never be satisfied with that one way. Because if you learn it one way and you don't use it every single day, you'll forget it in a week. But learn it one way and then saying, okay, now that I know how to do it, I'm going to try and do it another way. Now, if you fail to do it the other way, you know that, well, I can get to it this way. So, I at least get to it this way. So I failed to get it this way. So I know what the right solution is. I know what I need to get to. So I'll see what's wrong with this way. But if you never got it right the first way, you'll never figure out what's wrong the second way. So you got to get it right the first way, which is usually basically the canonical way, or, the textbook way, or something like that. But it doesn't have to be the textbook way. It could be the friend's way. It could be a parent's way, brother way, sister way, Anyway, so anyone who teaches you one way to do it, just pick it up. And then don't stop there, okay? And I think I don't know if I told you this guy. I told this to you guys or to my 2C. Actually, it has to be you, because I haven't had a meeting with my 2B guys before. Is that I don't know. Now I've forgotten what I want to say. All right, so that's all. I don't have anything to say anything more to say. If you have any questions for me, I'll try and answer them. Otherwise, the stage is all yours. Okay. Any questions for me? No? Okay. All right. Now I'm going to get ready for some entertainment. Okay. So I'm just going to be listening to you guys. So take it away. It doesn't have to entertain me now because it's your first time, but it will entertain me. When you're in my 2B and doing these meetings continuously, you will know how to create an interesting conversation about a topic that most people out there think is totally boring, right? So you go to a random person out there and say, hey, do you want to learn how to do ternary operators? Yeah, come on, I got a game to watch on TV, right? So they'll just run away. Because for most people, these are boring. But you can figure out a way in which this is a way I can take something that is perceived as boring by other people and make it interesting. Right? This is a very incredible skill to have. An incredible skill to have is to take something boring and make it interesting or beautiful or some way valuable so that people want it. And the reason it is useful is because you can now use it outside of computer science too. Right? If you develop the skill, like I said before, right? The skill you've learned now, one way of doing it is in math or in computer science. I've taken this extremely abstruse theorem that nobody understands and nobody can even relate to, and it's of no use to practical life, right? But I've tried to take that and make that interesting. Now, if you actually go to Facebook and YouTube, you'll see hundreds of videos today, right? Saying, here's this mathematical theorem. right? Nobody ever has found any use for this theorem, okay? And in fact, most people say it is the most boring theorem on earth. But at the same time, these top mathematicians have spent like 60 years or 70 years of their life trying to work on this theorem, okay? How could it be that most people don't even find it interesting and these people find it so interesting, right? But what you'll see is that you can take something and try your best to say, well, even though that is so uninteresting, I'm going to try and make it interesting. And then what happens is your brain will kick into some kind of mode, I think, where it's going to try and find things outside of the domain that it can relate to it, right? And when it starts doing that, you will start relating to these other domains too. And that way, you can actually become a fantastic conversationalist anywhere you go. It doesn't have to be in this video. You could be at a bar, right? Talking to someone next to you. And you could be, in a party. You could be anywhere. And all you need is for someone to say anything at all. And it doesn't have to be, anything that you're interested in. It could be totally boring. All you need is just ask a couple of clarifying questions, just to relate it to what you already know. I say, is that okay? And then you can start, making that interesting, right? You can have a conversation that will be interesting no matter what. So it's a very useful skill to have. And that is how people become very successful talk show hosts. And now anybody could become a talk show host, right? Because you don't have to have a half-hour program or 1 hour program. You can have a 5-minute talk show now. So there you go. It's a fantastic opportunity. Just go and then maybe you'll just fill up YouTube and Facebook in a few months with lots and lots of videos that come up in my feed saying, hey, you were interested in this particular way of this algorithm. Here's a video that was produced by a bunch of students, right? Talking about something that's related. And it comes up on my feed. I say, hey, I recognize these people. That's Emily. That's Vincent, right? Okay. So I could say that, right? And that'll be fantastic. And so use this as practice, right? Everything is practice. College is practice for you, okay? Once you leave college, it's not practice because, people are going to start paying you, right? You can't say, well, I took your $5,000 and I blew this machine, but don't worry, I was just practicing. I'm practicing on it, right? It doesn't fly when you're in a job, okay? But now you got total freedom, right? So you are here and being given the opportunity to fail, okay? Given the opportunity to fail, which you will not get once you leave college, okay? Once you leave college, when you fail, it's going to look bad on you. But now you can fail to your heart's content. In fact, fail as much as you can, right? Fail as much as you can in your whole life in college, and then after that, you won't have any failure. How about that? Okay, so that's all, right? I shouldn't take up any more of your time. Just if I give me a chance to talk, I'll keep talking. So don't draw me in unless you actually have something important for me to say. All right. So I'm just very glad to see all of you, especially with the cameras on. It's just a colorful, screen with so many different things. Starting with San Francisco Bridge and all these interesting things, right? So absolutely fantastic, right? Just looking at your faces makes my day. Thank you all. Okay. So, and the last person out, just call me. I'll switch off the lights, basically, turn off the video and the recording, and I'll post it on YouTube after, after it downloads and all. Okay. Is that all right with you guys? Hands up if you guys want to take it away. All right. Great. Thank you. All right. So there's at least a couple of people who are able to get started right away, and eventually people will start easing in, and everybody will have a chance and a conversation. Fantastic. Thank you. And call me, okay? I'm just going to be around. I'll be around. I'll be behind the screen somewhere. Even if I'm in the next room, I think I can hear you. Okay, I'll come back.
So I can share my screen for this printf thing. Like I understand the printf, but
So I found something on Stack Overflow. Pull up your screen first.
I mean, I know how to use it. It's just for my specific problem.
Yeah, so let's try C out. You want 6, or you want to truncate the decimals, right? That's the problem.
So before we move into that though, Kyle, are you using get string to do your conversion?
You mean like in my actual code, like not this example?
Right. Because I was having the same problem, but when it printed a whole number, it was like saying like 4.0000000.
Yeah, so I did my own kind of fix for that. So yes, I did do like the dot toString. Basically, I did like dot toString double or whatever.
So
That's
if
probably the
instead,
reason why.
Mhm.
Because
had-
two string gives 6 decimal places whenever it's like any number. So even if it's a whole number, it'll give 4 point and then 6 zeros. Okay.
so doing the O string stream will fix it for you.
Yeah.
So you don't have to do the fix for the fix for the fix
Okay, and does that make it so it's like 6 total decimal places?
when it needs to be.
So because like I see in his output, like for example, 41.3084, it's like it's always 6 total digits where it's like for in this case it's 4 decimal and 2 whole, but then on this case it's 1 whole and 5 decimal.
Yeah, I was having the same
Right.
thing, the same problem, and this fixed it by
So
going
just like
to
the
O
two
string.
string thing. Okay, so you're saying that should just kind of like make it into that format, into this format?
It did for me.
Okay, all right, sorry. I'll look at that later then. I think
Wait,
that's
so you completely lost me. If you were to type it in, what would it look like?
you mean using print like using this?
Using the O string stream.
Oh, that
You can
two
find it
string-
in one of the resources. I can share my screen for like the certain one where it shows the string conversion if you want.
Okay, yeah.
Could you do that?
Yeah. So I think I'm just missing that.
Um, it's this right here. So it's just gonna look like this, except you replace S with whatever string you have that you want to change.
O string stream convert. And then
So-
convert string.
So C is like basically the double here, and
Okay.
S is the string.
Okay, wait, hold on. So O string stream convert less than C is your double. What is S?
S is just a string values. Like say you're storing it in like an empty string.
Oh, it's empty. Okay, so S equals, and then you're assigning convert dot string.
Yeah, which is
and
the decimal
number.
in a string form.
So in the after the dot string in those parentheses, what's your input?
You don't put anything there. I think this is the part that just actually converts it into the string. Wait, I can
Oh,
like
it's converting to a string. Okay, but then how do
Yeah.
you truncate the decimals? Because that was the problem, right?
You don't have to.
Yeah.
It just does it.
it
In
automatically
the
does
form
it.
that he wants, in the form that his
Okay.
program is checking for.
Okay, cool.
I can stop sharing my screen then.
Okay. One question I have at this point, how do you make like a header file separate from your CPP file?
When you name it, just put .h, it automatically converts it if you're using VS Code. I'm not sure about
Oh,
other
you can
ones.
just put, I am using VS Code. You can just
Okay,
put
yeah.
a .h when you're naming it.
Yeah, instead of .cpp, it automatically converts it then.
Okay. One more thing was the ternary operator. So why would we use it? Isn't it just the same as like if else? It's like,
I mean, I guess it's like a way to like simplify your code in a way.
I think maybe it's just a thing that exists because you can do it in one line, whereas if you do like if else, you need 4.
Yeah, but I probably wouldn't suggest using it for more complex problems because that would probably just make it more like confusing in a way.
Yeah, for me, the if else is much easier
Yeah.
to work with. But maybe that's just because I'm new to coding as well, right? Because the syntax is more human.
Oh, so Richard, the set precision, I think that like sets like the total number of significant digits, basically, right?
I think it's
No,
decimals
set
actually.
precision also works, but then it just requires more code. So I think the way you're doing it there probably wouldn't work for this type of program because you have to put it because you're not printing it out, you're just returning the value, I believe, right? So it most likely wouldn't work for this unless you create like a whole new function which just does the precision.
Oh, you're returning a value, not printing.
I think that's what
for this one you're returning a really big concatenated string.
But it has to be a string. Okay.
Yeah.
I see.
So I think this would only work if we're printing the value out. Or an alternate way to do it is just creating a new function called set precision, which solely focuses on like converting the decimal number into one with like certain decimal places.
Oh, okay. I mean, I wouldn't this work though? Because like let's say I have like value, like a double value that is the number possibly with more digits. If I just call set precision on it, and then I put a 6, I think.
Are you converting it to a string though? Because
Well, then I
because
would
once you
say-
do two string, it automatically adds 6 decimal places regardless. So they'll add zeros in the end.
Okay. I made my own thing to get rid of that, but it's, I mean, definitely not a nice thing to do. So yeah.
Yeah, it would be more confusing.
Okay, so yeah.
Wait, so it does 2 underscore string and then parentheses. Does that mess up something here?
It automatically return. So
It'll
when you're
add
doing
zeros.
it from like a double to a string, so no
Yes.
matter what number you put, it'll give exactly 6 decimal places there. Like no matter what. That's
And
what
what we want is 6 what? So like 6 not significant figures, but 6 digits. Right. Okay. So that would not work and you'd have to adjust things if you used 2 underscore string. All right, do we want to try an activity? If there are no more questions. Like the bullet going off the cliff or something. Thoughts, opinions?
does anyone have any ideas on what to do?
Well, I'm not sure how we would do the bullet going off with printouts. I could totally see how you do it with like just values, like at this time, this is the velocity, at time equals 2, this is the velocity. But I don't know how you'd actually convert that to like a printed path of asterisks.
Oh wait, one more thing though. Just like I'm just curious for your guys' e to x for the quest number, what is it for? Like this, it's like the second e to x we've done. I saw like a Reddit post that talked about like keeping a whole, like keeping different doubles for numerator and denominator. But did you guys run into the same problem as I did, where it's like the denominator and then like, you know, with the factorial, right? It got too big. It got like too like bigger than like a uint 64. So did you guys run into that issue? I was able to just to do it like a different way that was like a lot simpler.
I made my double effect. I made factorial variable a double in my case. I'm not sure about anyone else because doubles, I believe, have a longer, can hold more bytes. I think compared to ints, I'm pretty sure double holds more.
Yeah, just like, but like for the factorial, like for example, like 22 factorial is like bigger than a 64-bit number.
Did the questing side give that as one of the things?
Yeah, so I mean, what I did at which was just like way simpler, I just realized is like every loop, you're just like multiplying by something in the numerator and then multiplying and dividing by something in the denominator. So like you could keep the number small by keeping your previous answer and just multiplying it again and dividing it again instead of like redefining a numerator and a denominator. It's just, I'm curious if anyone else ran into that issue where it's like the numerator and denominator, if they did it that way, got so big it just did not fit even in like a uint 64.
I did not run into that problem at
Okay.
all. I'm not
Because
sure about
mine
anyone
passes.
else.
It's just okay. Because like 22, like for example, like one, you know, one of them was like 22, right? 22 terms. And like, you know, in the denominator, it's going to be like 22 factorial for the last term. right? And like we know that 22 factorial is massive. It's you can't even hold that in 64-bit, I think. So anyway, but I guess maybe, yeah. I mean, I just figured it out by like keeping the previous answer and then adjusting it by another numerator and denominator. So I never have big numbers, but I don't know. I just saw a Reddit post that talked about like keeping them separate. And I was like thinking that wouldn't, like that doesn't really seem to work. So yeah.
Okay, so I haven't gotten here yet, but I assume the problem is with like the factorial being too massive. So why would it matter whether you redefine the entire numerator and denominator or not?
Because like for the e to x, right? What's the formula again? It's like a to the, I mean, a to the,
It's like 1 plus,
yeah, I mean it's basically gonna be like a to the j, where j goes between 0 to n, over j factorial, where j goes from 0 to n.
you could just hard code like 1 plus x squared over 2 factorial plus x cubed over 3 factorial, right? You don't need to use the formula.
Well, but for this one, it tells you the size, like how many terms. This is for the second.
Oh, you do need to use the formula. Okay, okay.
And I'm just saying what I was running into is like if you do like recalculate the numerator and the denominator every term,
Yes.
the denominator gets, I mean, like too big, right? Because if it inputs 22 terms, which he did test, 22, that means the denominator would be 22 factorial for the last term, right?
Okay.
Do you guys agree? 22 factorial has.
Although I didn't run into the problem, another thing you can do is if it can't hold that byte size, you can just change like the variable type. So if I have a double currently, I can make it a long double, which is like the largest, like the double can
Long
be.
double.
Yeah, or is it long double? I don't know if it's just one or two.
Well, I did long. I mean, I did like uint 64, which is just a 64-bit unsigned integer to hold the factorial. And even that is not big enough. Long.
Wait, but why did Divot not run into that problem?
I didn't run into that. I just used a normal double, and that worked out.
And it just worked?
Yeah.
Did you do something differently in your
Did you like solve for the
code?
numerator and denominator?
I did that all in one loop.
Okay. I mean, but did you use your previous answer and then modify that number? Or did you like resolve for a denominator and numerator every time?
I didn't resolve the factorial because like every time it
exactly.
iterates,
So
I just
you can
multiply by the new number.
So if you resolve the factorial, then you run into
an issue. Yeah. So I ended up doing it your way, where you just, I mean, it makes a lot more sense. It's a way more simpler. So
yeah, like think about it. If it's going from 5 factorial to 6 factorial, the next number, you just need to add the 6 in. You don't need to solve the entire factorial itself.
Hold on.
Yeah, I was just curious if someone else run into that, because like I saw a Reddit post talking about how like you like solve for the numerator denominator separately.
Let's say you resolve the factorial, but it's in the denominator. So every single time you loop, you do like some variable equals numerator over denominator. That value would be small enough, right?
Not if you hold it separately. But if you hold it separately, then no. But if you
but the number you're trying to print is dividing. Like it's 1 over
okay.
something.
So like I don't know, double A equals 22 factorial. That's a problem, right? Because 22 factorial is massive. But double A equals something over 22 factorial. That's fine, right?
I guess maybe
I should just try it.
Because I had an external function that was factorial, and then again I realized that this was really inefficient, and I basically did it your way at the end, Divot, where you just kind of like use your previous answer and then just multiply
by the next
which
value.
Is totally makes sense. But like when I had like an external function that solved for factorial, again it's inefficient. Even with a uint 64, which is 64-bit, which I think is the same as a long. It was too big.
The only time I run into a problem where like the bits were like too like the value couldn't hold it was in the Fibonacci sequence one, because like it wasn't able to calculate like the 47th term or the 96th one.
Okay.
Wait, hold on. Even if you store the old value and then multiply by, let's say I'm on 21 factorial, I multiply the last value by 21, all right? That's still just as big of a number. So why would you not run into a problem there?
Because what I did was to avoid that problem, instead of holding, and again, this comes back to my question. It's like I saw a Reddit post talking about keeping the numerator and denominator separate, which like I feel like then you'd run into the issue. So like what I did was I did not keep it separate. I just
Oh,
held
you never
my-
kept them separate. Okay.
Yeah. So then it's
So,
always
okay,
going to be
okay,
some
I see.
decimal that's like reasonably small.
That's not massive. Okay.
Yeah. So I never kept them separate.
Got it.
Wait, so you were saying for the Fibonacci, I actually haven't tested that one yet.
That was the only time I run into the error. Like
How high did it get? How high did the N get?
96 or 100 something. They did test like Fibonacci 101 or something like that
Okay.
at some point.
Did you do it iteratively or recursively?
I didn't do it recursively. That has such a long run time.
Okay, let me.
Recursively doesn't work. I tried it, and it gives you like, yeah, it gives you a runtime error. So I think you have to solve it.
Yeah, because it goes from like, if you give like a number like 20, it has to go 20 and 19, then 19, 18. So it takes way too long. It only worked for like smaller amount, like smaller numbers.
So you said like 101?
Yeah.
Okay.
Try 47, 96, and 101. I believe those are the ones that I had, like, those are the numbers that gave me an error when I tested the questing site.
Hey, just making sure because I'm new to this, right? When you say recursive, you're calling some function Fibonacci sequence over and over and over again for n equals 1, n equals 2, n equals 3, blah, blah, blah. Whereas for iteratively, you like take the last value you had and then work with that.
The function calls itself for recursive.
Yeah.
The function calls itself.
Yeah. And
It's a
then
bit, it's a more confusing concept. It's probably not something that,
I'll worry about that later.
yeah.
So when you ran into that issue where it's basically too big, did you
I did just change the type.
the data
of-
types? Okay.
Yeah, for all the variables that were being held.
Because we can do like unsigned ints. Like
It didn't work.
64.
Yeah. For me, I used let me see. I had to change it to double. So I used like long doubles for all the variables because that was the only way that the code was working for me. I tried the largest int possible as well, which was unsigned long int. It didn't work for some numbers.
Oh, float
So-
works too. I used float.
Yeah, there's
Okay,
the
float.
flow and double, I think, are pretty much the same for this one.
I thought like a uint 64 was like the biggest. I guess that's wrong.
When you just type out int, is that assumed to be signed?
Yes.
Yeah.
So you have to specify.
You have to say
unsigned.
unsigned int, yeah, to specify that.
I'm gonna try uint 64. I feel like that should work. But I mean, maybe not.
I have to leave early this time, guys, but it was great. It was already a big help. Thank you.
Thank you.
Does anyone have any other questions about anything else?
I'm genuinely curious now. What is what kind of variable can store the largest number of digits? Do we know?
You can probably just search that one up.
Well, I'm trying to search it up and I still can't find it. So that's why I'm asking.
Wait, so you said long double?
Is that a
Yeah.
thing?
No, just long double. You can't do long
Long
double.
double.
Wait, long int.
What I don't understand though is why we don't need a double here because they're all whole numbers. So it's like I feel like that's a
No,
waste of
doubles can
space.
hold more though. So when
Okay.
the more than an int, so when you add long to it, it just increases the size. And the largest data type is any with long in it. Pretty
Any with
much.
long in it.
So long is the largest integer one there can be. So yeah.
60.
Okay, yeah, that works actually. So 101 works with that.
With which one?
Long double.
Did
Long
you
double.
try the one you were saying before, the AU64? Did that work?
Yeah, and it didn't work, which I'm a little. Let me see. It goes to the 20th. So 20. Let me put this number into like just like a binary converter and see if it's 64 bits or longer.
Wait, so you used long int and it worked.
No, long double.
Long double, okay.
Even though it's a whole number.
What if you use long int?
I think a long int is 64. So that's not
We'll
enough.
just try it.
I believe long double is 16 bytes, I think. So that's why it's able to hold that.
Long double.
Oh no, a long int would not work because that's like signed. So
How about unsigned long int?
I don't know. Look that up. I'm doing something else.
Okay.
I think I tried like all of these values at some point when I was on that quest.
Yeah. All right, it looks like we've probably exhausted our questions by now.
So yeah, the Fibonacci number, the 101 term in binary is 85 bits. So
Okay, so
a
64 is not enough.
Uint 64 is not enough.
Okay.
I think long double holds 16 bytes, which is enough.
Yeah, so that's what
Which is
1600.
massive. So it's
Yeah.
like what,
128.
128?
28. Yeah.
128? Okay.
So I think it hold most of it then.
What quest is everyone on? I have not started the quest they're talking about, but they're talking about quest 4, right?
Yeah.
Yeah.
Yeah, I'm finishing up 4. I just, I didn't get the
4 is the
GP,
one
whatever.
that's due soon, so. Yeah. All right, well, I'm gonna hop off the call, but this was helpful. You're on quest 6.
Nice. I'm on
Pretty good.
quest 8.
It's pretty good. On
Almost
quest 8,
done with that. Yeah.
going fast. Although the initial few quests are like much shorter.
Yeah.
So yeah. All right. Well, I'll talk to you guys next week.
Thank you for the help with the data types. All right, bye.
I think I'll probably hop off as well then. All right. See ya.